All right.
Hola, muy buenas tardes a todos. Bienvenidos a esta nuestra penúltima sesión del día de hoy en este grupo del evento de comunidad de usuarios de Latinoamérica de Oracle. En este momento, siendo las 5 en punto en Costa Rica, damos inicio ahorita a la sesión en donde tenemos un invitado también muy especial para todos. Sandesh nos acompaña hoy desde la India y ha venido acá a compartir su conocimiento. A partir de ahora la sesión va a ser en inglés, pero podemos recibir sus preguntas a través del chat si quieren en español y las traducimos. Sandesh nos ha prometido que para el próximo año nos va a sorprender con su español y va a estar un poco más fluido acá en esta presentación. So I was giving the welcome words for the people,
I
Sandesh.
understood most of it.
Great, that what I was telling to
Muchas
them that
gracias.
next year you're gonna do your presentation in Spanish and hopefully here in presence with the people. So
Oh, yeah.
in behalf of the organization, I give you the thanks and the welcoming again, because I know that is with the time difference it's hard to be at this time, but we appreciate that you are here, that you finally went through this meeting. We are going to receive some questions from the public at the end of your presentation. So I invite everybody to share your pics, your comments in social media. I'm going to write down the hashtag in the chat. So Sandesh, again, welcome and enjoy this session.
Thanks a lot. So thank you so much. Buenos días. Espero que todos estén bien hoy. Mi nombre es Sandesh Rao. He trabajado en Oracle, en diferencia tecnología como database. RAC Oracle Enterprise Manager. Actualmente he trabajado en AI Ops. La sesión de hoy es sobre inteligencia artificial automático en Oracle. Espero que esto sea de utilidad o a la próxima vez que presente español. ¿Está bien? See, I think I can speak Spanish, so maybe I should have practiced a little more and I would be able to actually do this whole presentation in Spanish. But thank you for the warm welcome. I did understand most of what you said. And so this session is going to focus on AI and machine learning within Oracle and all the technologies available to you. It will take me maybe about 40 minutes to go through this presentation. If you have any questions, please put them in the chat and I'll be happy to answer them. All right, with that, I'm going to switch. Can you see my screen, my presentation? Give me a second. Let me just verify I'm screen sharing. Yes. Okay, cool. So first and most important.
We're seeing your presentation.
Thank you so much for confirming. So first and most important, everybody asks, how do I get this presentation? So take a picture of this slide. And if you want to connect with me, this is my Twitter. If you want to connect with me on LinkedIn, this is my LinkedIn. And these slides will be available on this link after this presentation. So these are the different ways to get access to me and also gain access to these slides. With that, let's get started. So there are four major kinds of machine learning we work on at Oracle, and this is where majority of our projects fall into. The first one is supervised machine learning. So supervised machine learning, meaning you can predict outcomes by the basis of training data that's actually provided by human experts. This used to be the most common method of machine learning earlier, but now it's basically called an expert system. As machine learning became more mature, we started moving into this category, which is semi-supervised machine learning, which happened to be the most prolific growing area where you can discover patterns using raw data and you make predictions. And then human experts review them and they provide feedback, and that's actually used to improve the model accuracy. The third category, which has become very popular lately, is called unsupervised machine learning. So this allows you to find patterns without any external input apart from just the raw data that's there. So this is very popular for discovering, like, stolen information. If you have social security data, credit card data, or any data that could potentially compromise you, or any sort of trends based on different kinds of data formats, the method that is used to analyze this is called unsupervised learning. The fourth method is called reinforcement learning. We use reinforcement learning for a lot of things inside Oracle, especially to detect if something is deviating from a certain norm, anomaly detection related stuff. But mainly, reinforcement learning is used based on past rewards for a specific type of action and is used for gaming. So, gaming uses reinforcement learning very heavily, but lately, a lot of neural networks are also using reinforcement learning for their analysis. So these are the four major high categories of machine learning that we play with. The most common flow when you are doing a machine learning project is you basically help set the business objectives. You find out what the project is supposed to do. Say, I'm supposed to detect fraud in credit card transactions, right? Then you get all the data and you clean it. You clean it so that the data does not contain anything wrong. Data types are clean. All the column information is properly represented. These two take the most amount of time in a machine learning project. The third one is to identify and extract the columns, which are also called features, from imported data. Now, what this does is it helps to identify the efficiency of the algorithm. So, which algorithm to use, which one to apply, and which columns to apply them, or which features to apply them on. This process is called dimensionality reduction. So what we do is we try to figure out which columns to mine so that the machine learning algorithm becomes really accurate. And it can say, oh yeah, I'm going to be able to find out this information based on analyzing information from these columns. The fourth step is called training data. So what you do is you take the data and you split this into test data and training data. So the test data allows you to test the outcome of your model, whereas the training data helps you train the model and see how accurate it is. Now, in order for this model to work very well, you use something called hyperparameters. Hyperparameters to an algorithm are input values. They're like init.aura for a database. So in order for machine learning to do its thing, you have to have the right value for these hyperparameters. And once you have the right training data and the right algorithm, you basically get a model. And you can keep training that model till it actually gets really good to doing what you actually want it to do. So this is a regular machine learning project workflow. In most companies, we use this as well. There's a big difference in the training cycles lately. We used to use machine learning to do all the training. Now we use something called AutoML. And what AutoML does is it basically uses repeated training cycles to make the process of training much more simpler. So it basically picks the algorithms, it does the feature selection, it does the tuning, and it says, okay, this is the right model. And then it keeps going back on this direction to make the model better and better and better. So this thing is called ML versus AutoML, where AutoML is kind of the method that is actually used today to do most of the training across the company. Does AutoML remove the need for data scientists? It doesn't. What it does is it takes away some of the most common things you do when you build a model, but it gives you the ability to do more. You can spend more time engineering predictive features. You can develop data acquisition strategies, and you can build something called data transformation pipelines. So AutoML, while it accelerates the whole process of machine learning, it doesn't make the data scientist obsolete. It just improves your ability to do more models and train models better. Now, Oracle's got this basic Oracle machine learning framework within the autonomous database and within the on-premises database. So if you downloaded Oracle 21C, 21.3 on your systems, you can actually do a lot of these things on the database. So what does the database have? It has in-database machine learning algorithms. And the advantage of that is it basically requires no data movement. You have all your data inside Oracle. You can basically run these high-performance parallelized in-database machine learning algorithms on top of this data. And you can quickly deploy, you can update these notebooks and models, you can deploy them via SQL and REST, and you can also use R and Python functions to manage this thing And it also uses the data parallel invocation. So I'll talk a little bit about that later, what that is. But basically, if you're using Oracle machine learning in the autonomous database or on the on-prem database, what do you get with the autonomous database? Let's start with that. You have a model repository, you have workspaces, you have AutoML. So it automatically takes and runs different varieties of algorithms against this. You can deploy the model using REST, and you can also manage your model. All of these features are available in autonomous. Some of these features are available in on-prem. For example, AutoML at the moment is not available in on-prem. Workspaces, you have to manage your own workspaces, but you can build like a whole Jupyter notebook library on this. By default in autonomous, we make use of something called Zeppelin notebooks. So if I go to the next slide, this will show you a more clearer way of how you can interface to the various systems that are available, right? So this is the Oracle Autonomous Database Platform. So you can create an account for free, and you can use some of these machine learning features. You access them using the Apache Zeppelin notebooks, and these are the OML notebooks. You can write machine learning code in SQL, in Python, or in R. You can use any one of these methods. The next one is if you're using SQL Plus or SQL Developer, you can write everything in SQL. You can use something called OML for SQL, and you can either connect to the autonomous database, or you can actually connect to the on-premise database that you have sitting in your data center, or the Oracle Database Cloud Service, where you just taken a machine and you're spinning up the Oracle database on it, and you're not using the autonomous database for all of this. You can directly connect SQL Plus and SQL Developer to these databases and write machine learning code using OML for SQL. Now, if you have Python clients and Jupyter notebooks, you can use OML for Pi. What OML for Pi allows you to do is it uses Oracle machine learning with a Python interface where you can write code and mix code with other Python libraries from other vendors. And you can deploy these things within the Oracle database or within the autonomous database as well. If you do this using R, you can use a R client or R Studio, and you can write the code in OML for R. So there are so many different ways of how you can do this. If you're using SQL Developer, then there's something called the Oracle Data Miner. It is a utility that's present inside SQL Developer that allows you to model your entire application. And you can basically use that also to interact with the machine learning interfaces inside the Oracle database. So 5 different methods of how you can access the machine learning platform inside Oracle, whether you're using the Oracle Autonomous Database or whether you're using the on-premises database that you've downloaded, which is 21.3 or 19.10. With every on-premises version we release new algorithms in it. So you can run all these algorithms locally on your own data center. You can not just interact on a specific kind of data, but you can basically play with relational data, which is what majority of us have. And if your data is in JSON, you can play it with JSON, graph, spatial text, any of this kind of data, you can basically interact with. And you can build workloads and models for machine learning, for IoT, and you can also integrate all these microservices and events, all of this into the Oracle database. So you can make the Oracle database a single machine learning platform operating on top of all sorts of different kinds of data. So whether you're a developer, a DBA, you can use this platform to manipulate your data and to build your machine learning functions. Now, if you're using the autonomous database platform, what do you get? So this is a screen of this thing, right? So you can use machine learning for Python here. This is the code, and these are the box plots that are there. And again, this is the code, and these are the graph plots that are there. These are various machine learning notebooks. As you can see, there's a panel of stuff out there. So all of these are based on Apache Zeppelin, as I had mentioned earlier. It's intended for data scientists, application developers, DBAs, and if you know SQL and Python, you can actually use that. You can share your notebooks, you can schedule and version and access control your notebooks. And along with the autonomous database, this is all managed and provisioned automatically. So you don't have to do anything. Once you create a database, you have access to this entire notebook infrastructure that you can start writing machine learning code without actually having to install anything. You have access to all the in-database algorithms as well as the analytic functions. You can score models, you can deploy solutions, you can do everything using the autonomous database. Now, these are all the functions and algorithms that are available for you if you're using the Oracle database to write machine learning code. The most important ones are classification, regression, and clustering. These are three that are used for most work. You can use attribute importance as part of AutoML to filter the columns that are actually used as part of your models. You can use anomaly detection to find anomalies in your data. You can use time series forecasting for any kind of data that is renderable in a time series format to track trends, seasonality. So anything with trends and seasonality and anything with the irregular time series can be done using the time series algorithms. Now, one thing that's very popular here that people don't usually understand is this one here. You can write simple statistical functions, whether it's min, max, median, standard deviation, t-test, f-test. You can write all of these by basically writing simple SQL on top of your data. So you don't have to write just machine learning code inside Oracle. So if you have all the data sitting inside an Oracle database, you can actually just write simple statistical functions. If that's all that is required, you can use statistical functions and SQL analytical functions if that's all that's required for you to do your job, right? But these are all the algorithms that are available as part of the Oracle machine learning libraries. There's a couple of algorithms with a star. These are the ones that are available in 21C. So we'll go through this as we go further in the presentation. But the three most important areas are classification, regression, and clustering. These are the most common areas where all these algorithms are used, and most of the use cases fall under these areas. Now, why should I use this inside the Oracle database, right? So first of all, and the most important reason, there's no extracting data. So when we used to write a lot of code using third-party machine learning libraries, we used to extract the data outside the database, process it in data frames, and import the data back after writing it down to file system. So this requires twice the space, requires a lot of time, and we didn't want to do that. So then we decided, why not just have the machine learning engine inside the Oracle database? First of all, it's faster because you're not moving any data. It's more scalable because the data is already inside the database, and you can scale up using the Oracle parallel query infrastructure. And then you can use something called Exadata storage tier function pushdowns. So for those people that are not familiar, Oracle has a platform called Exadata, and it has something called a storage tier inside Exadata. So sometimes when you're accessing huge amounts of information, the call from the database server goes down into the storage server, and it has the ability to filter things down at the storage server and only return the relevant information back just to the database servers. And that's called Exadata storage tier functional pushdown. And that is used as part of this to perform batch and real-time scoring at scale for these algorithms. So this thing is really fast. It's algorithmic specific. And the most important is the prediction details can be explained. It's called explainable AI. And explainable AI is very important because how did you analyze this? And how did you come up with these results? And if I want to actually consume your results, I have to believe what you have done is correct. And that thing is called explainable AI. The second most important thing is machine learning models are database objects. So you cannot just apply access control or audit them, but the most important is you can export, import these models. So I can write code here in the autonomous database, and I can export the model and bring it here, which is where I'm sitting here, right? And I want this data. So I do all my training here, and I bring this information here to this is my data center. And this is the cloud. So I can bring the model from data here after finishing the training in the cloud. And I can use this for all my on-premises databases. So this is really good, where you can actually export, import models across databases, okay? There's another couple of other things you can do, but this is one of the coolest features. So don't have to move the data outside of the database. And second is the machine learning models can be exported from the database and imported into an on-premises database, and you can use this on top of your data. So here's a simple example of how to do this. So the procedures here are DBMS data mining, create a model. I'm setting auto prep to on, and I'm using support vector machines as part of the algorithmic name. I'm using a classification function. I'm running the query, and in this case, the column customer ID and the target column ID is this. So this is the ID by which I will uniquely identify the records. And this is the target column ID, which means I want to find out which customers in this list are likely going to buy travel insurance. After I do this and I run the training, I can basically run a prediction probability and say, using this particular example, I can say, what is the prediction probability? So it's a 92% probability if a person is going to buy this insurance, where the funds are 3,500, the 37 is age, they're married as a marital status, and 2 is the number of pre-cruises. So these are examples of how simple it is to build a machine learning model for a classification using support vector machines and writing a small piece of SQL to train this thing. So this is OML for SQL. I think there was a session before me. I think it was Adrian or somebody else was presenting on this. I hope if you've attended that session, they've gone into details on what OML for SQL is and how you can use that. So what's new in database 21C? In 21C, the first and the most important one is this thing called the extreme gradient boosting trees. Now, XGBoost is a very popular algorithm for gradient boosting trees, right? If you want to use for those algorithms, it's used for classification, regression, as well as ranking algorithms. It is highly popular. It is extremely powerful. And we've managed to tie it closely with the Oracle database so that it actually operates at pretty fast speeds on top of data that actually sits inside the Oracle database. So now we have native XGBoost support as part of the Oracle database. The second one here is called multivariate state estimation techniques or sequential probability ratio test. Forget what this is, just call it MSET SPRT. And what it is used for is it's used for anomaly detection for sensors and IoT. And it can detect anomalies without actually, without producing any kind of false alarms. So we use this internally as part of an anomaly detection service to do any look for sensor IoT data or machine data, like CPU consumption, disk consumption, and see if there's any kind of failures that are detected based on using MSET SPRT. The third one, which is a neural network, we have two different functions which we had enabled. One of them is called Adam Solver. This is a mini batch solver. Requires very little memory. It's very suited for large data sets. And there's another one is called the ReLU activation function. And this basically is a it's a kernel-based RBF driver. It's used to train models with much, much better performance. If you're a machine learning person, you've heard of Adam Solver, you've heard of ReLU activation functions, you've heard of XGBoost. These are the same functions that are implemented in a slightly different way so that they actually function very well in an Oracle environment. Now, one thing we have added is we added enhanced prediction details. Now, what does that mean? That basically means you will understand the factors that most contribute to a prediction. I told you this earlier. One of the problems with most of the algorithms is the explainable AI part of it, which means people can say this is how the algorithm should be, but they don't understand and they can't explain how this algorithm works and it came to that conclusion. So I can say this is the algorithm you should use, but here's why you should use it. That's what we do very well as part of this. And this prediction details has been added for 4 different kinds of algorithms: for SVM or support vector machine, generalized linear models, or GLMs, neural networks, as well as the last one, which is K-means. So we've added better enhanced prediction details for these 4 algorithms. This is a user interface of Oracle Data Miner. This is again an extension for SQL Developer, and this can be used for both on-premises as well as anything in database cloud services. And it's a drag and drop interface, and you can quickly build analytical flows, and you have access to all the algorithms, and you can generate SQL code for immediate deployment. So if you're a machine learning guy and you want to start learning something on your on-premises database, you can actually start using Oracle Data Miner, which is part of SQL Developer. And you don't have to write any code. You can just start dragging and dropping and you'll realize how quickly you can actually build something from this. And as you can see here, this is the by insurance table. And then you can see here, this is the multiple classification models that you can see. And this is the representation of the classical models and where the information is pulled from. The columns are filtered, the models are built, the most likely customers, and then finally filter it down to who's going to buy your insurance. So the whole thing is a graphical user interface for generating analytical workflows. And this is for citizen data scientists. You're a technical person, you understand the problem, but you don't know how to write a lot of code. You can use this to build what you want to build. So a quick summary of what's available on the Autonomous database. First of all, you don't need to move data. And you can democratize machine learning, which means you may not be a data scientist, but you don't need to be one. You don't need to know how algorithms work. You don't need to know how to train a model. It is all done for you. It's multi-language. There used to be cases where, earlier people would SQL who are very comfortable with writing these APIs. And then later there were people who were saying, hey, I'm a Python developer and I don't want to write all this stuff in SQL, or I'm a guy who doesn't know how to write any code. How do I do this? And we came out with all of these things for SQL developers, Python developers, and developers who don't want to write any code. They can all use this. You can access data from broader data lakes, which means you can connect to any other cloud, whether it is, you can connect to Azure buckets, you can connect to AWS buckets, you can connect to any external tables anywhere using Cloud SQL and pull this data into OCI and do your machine learning exercises based on this. So it's actually pretty cool. You have automatic model governance, which means your security, the separation of production and development, the country where you're writing these models you can keep these models in the data center near a country of your choice or in the country of your choice. So you have model governance. You can scale this. You can write models that go as to how much as data grows, your model grows. And the same thing, you can scale this elastically, right, as part of autonomous. I mentioned explainable AI. So you have the ability to explain why your model did something if something goes wrong. And this also gives you the ability to do ML ops, which means you can create models, you can query them, you can streamline them, you can produce ML pipelines, you can deploy them using REST. All those ML ops operations can be done using this. And you have the ability to use this on premises as well. This is pretty cool. And most of the ML capabilities are included in the core product without paying any money. So this is available for you to use, and it's pretty cool. Now, let's go a little bit towards R and Python, right? So we create something called a transparency layer. Now, what is a transparency layer? Now, for people who have used data frames, right? If you use pandas data frames, right? A pandas data frame is like an array where you load some data from a flat file or CSV file or a database, and then you can actually manipulate it. And then you put this array back after you write your changes into it. But so what lands up happening is all your data sits inside the tables inside the Oracle database. Now, I want to write a function in Python using scikit-learn to access that table. But earlier, what I used to do is I used to export that table as a CSV, and then I used to write a data frame to open that CSV and make changes, and then load this changed CSV back into the Oracle database. I don't have to do this anymore because we use something called proxy objects. So what we do is we create a data frame inside Oracle, and you can use OML for Pi to connect to this data frame. And it will look like a pandas data frame. It will even behave like a pandas data frame. And the backend data is actually sitting inside an Oracle database. So it's actually pretty cool. You don't have to remove your data from the database, but it will look like a pandas data frame. And then you can use PQ to create as many SQLs that you want to connect against this, right? And then the most important is OML for Pi also includes AutoML. So you can use algorithmic selection, automation, and models. And you can also use model explainability for feature ranking. So these are all the features that come in if you're writing something in R or Python. Now, here's a example of this, right? So now there are two pieces of this. I'm using oml.dataframe here, and I'm giving something called the iris data set. There are like 10 different data sets that are available as part of like a regular machine learning exercise. If you're learning machine learning, iris is one of them. Now what it does is it allows you to basically take petals and sepals and all of these kind of variation on flower species, which is part of the iris data set, and you can apply different models to it. So here's what I'm doing. I'm taking the OML data frame function, I'm loading the iris data set, and then I'm actually calling this function build underscore lm with parallel equal to 2. So this spawns off two Python engines, and it calls this function, okay? And then in this, I'm using scikit-learn. I'm importing a linear model, and then I'm using the linear regression algorithm. And based on this dat function that I have inherited here, so this one I'm building, I'm loading the iris data set into it. I'm basically extracting the petal width and the petal length, and I'm trying to predict the kind of flower based on the petal width and length. And I'm trying to fit the algorithm, and I'm returning this object back. So here what I'm doing is I've created the data frame, I'm applying the model using OML for Pi, and I'm pulling back the results of the model to see what the execution says. And all of this is being done by using OML notebooks, OML for Pi, REST-based interfaces connecting to autonomous database. Autonomous database spawns off two PQ processes for OML for Pi, run the scikit-learn code, and return the results back to me. So this is an example of combining Python and the autonomous database to do a simple execution using scikit-learn libraries. So you're a Python developer, you can easily write stuff using sklearn on top of the autonomous database. So this is where you actually access the AutoML related libraries. So this is sort of like it's sort of like a demo video. Give me a second. I'm going to play this because it's actually pretty cool. And so you go into AutoML, and then it shows you all the AutoML models that are available here. You create the AutoML thing that you want to create. So these are called experiments. And an experiment is something that's a combination of input data, algorithms, and stuff like that. So I'm just calling it customer 360. By default, I'm the OML user, so I'm just going to leave it as the OML user. And then I pick a customer 360 table that I'm loading from here. So you can see the data source has been picked. Then I want to predict the affinity card. What's going to be the affinity card values? And my primary key index here is going to be customer ID. This is a classification type problem. And then I'm going to, you can see it's actually picked affinity card as the target. So the target that has to be predicted. By default, it will show you min-max standard deviation values for most of these things. It will allow me to run how many models do you want to run, how long do you want to run, what database service level you want to use, and how accurate you want it to be. Do you want accuracy? Do you want high, medium, low? And then it also allows you to pick whether you want a AOC-based curve, you want an F1-based method to decide, and what algorithms do you want to pick, or you say just pick everything. And then you can run it for faster results or better accuracy. Better accuracy runs it longer, faster results does a couple of iterations and tries to pick the best it can find out of those iterations. Now, once you start this process, it will basically show you what it's doing. It's trying to pick the algorithms, then it queues the other 4 steps: adaptive sampling, feature selection, model tuning, and feature prediction impact. So it queues all of these things, and one by one it starts running them. Now you can see here, it's actually picked these 3 algorithms, it's created the names of the models, and while it's actually running this, these accuracy numbers will slowly start getting populated. So you will automatically, it takes different combinations of algorithms. It does adaptive sampling on top of the data. It does feature selections on top of the data. And then it tunes the model. And then it comes up with an accuracy score. In this case, you see the accuracy score for a random forest is 0.7534. And then as this thing finishes, it basically populates and shows you the scores of everything else. You can see the score in this case for the SVM is the lowest, and the score for SVM, so SVM linear is the lowest and SVM Gaussian is the highest, and it keeps iterating on the models to improve the score even further. So this is kind of a cool example of how this AutoML modeling works, and it keeps going and keeps iterating through all these various stages to give you a much better algorithm without you actually having to really do anything about it. I'm going to stop this. So what other things can you do with this? The most important thing you can do with this is you can build new projects really, really fast. It doesn't take too much time because it automates all your time-consuming tasks. It automatically, the insights function automatically picks the right algorithms, picks the right columns. So we went through the screen where it shows you the progress of everything, and you can quickly monitor this, and you can score this for real-time applications. And once you're finished, you can deploy this model as a REST endpoint. So basically, becoming a data scientist now with OML is very easy, even if you don't know how to do this, right? Now, there are 4 steps in an AutoML pipeline, okay? The first is the automatic algorithmic selection, which is what we were seeing. And the goal here is to find the best algorithm, okay? The second one is adaptive sampling. It's like the optimizer, right? So what the optimizer does when you're trying to query something from an Oracle table is it tries to do some kind of lookup, right? So it tries to look up the certain rows. It says, okay, first rows is better in this case, or should I scan and do a full table scan for the entire table, or should I do an inline, view merging, or should I do a temp table transformation? It tries to figure these things out, right? So what it's trying to do is, with the least amount of data, the optimizer is trying to figure out which is the best SQL to generate, right? And in this case, this process for machine learning is called adaptive sampling. So it takes a small amount of data and it looks for unbalanced data. And it tries to identify what is the right sample for the training data. That's basically what this adaptive sampling step does. For auto feature selection, it reduces the number of features by identifying which features will give you the best accuracy and performance. And then finally, it runs through hyperparameters and improves the model accuracy. So these are the 4 stages. Now, you don't need to do anything as a user for this. The AutoML framework does all this for you, which is kind of cool. A year and a half ago, most of this stuff didn't exist. Now, it is really easy to predict and use these things. Now, this is comparing OML for Pi and OML AutoML UI. I won't spend too much time on this. One of the reasons why most of this stuff is optional, because you have a manual pipeline. You can add your own Python functions into it. Whereas in this case, it's all built in, so you don't really have to do anything. You can also use Oracle Machine Learning for Spark. So you can run this across a variety of data lakes, and you can run this using a Hadoop cluster. And you can also use distributed ML algorithms from the Spark MLib implementations for running this across HDFS, Hive, and all these other Impala and other data sources. One thing you can do with OML services is, and the most important one is, there's a lot of stuff you can do with it. The most important one is using this, where you can exchange other models with OML. The procedure is called, the format is called Onyx, and it allows you to exchange models between third-party frameworks and Oracle's own frameworks. And so something you've built and trained internally, you can transfer it to Onyx to TensorFlow, or something you've trained on TensorFlow, you can transfer it using Onyx to Oracle's OML. So this is actually pretty cool. This is a service that you can use. There are different REST APIs. You can use username passwords to connect to the PDB and get this information, or you can connect to the OML mod object and run get, post, delete functions to do this from OML services. So these are the various REST related functions you can do, whether you're querying the repository or deploying it, if you're managing it, or if you're doing cognitive test functions. These are the kind of calls that you can execute. Now, the last part of this presentation, I just wanted to cover a different kind of scenarios of how DBAs and developers use this. So if you're using OML, AutoML, you can generate a notebook, build a model, and deploy it using OML. And then you can use an Apex app to query the data that comes from this model. Or you can use OML and deploy this directly inside OML services. Or you can use SQL and access this directly inside Apex. So these are three methods using OML, AutoML UI that you can actually deploy models inside your database. The same thing, you can use notebooks directly. So you don't have to use AutoML, but you can directly connect to OML services and deploy your model. Or you have a model already, you can import it, export it, and import it. So you export it from Autonomous and you import it in on-prem. And then you can deploy this as part of OML services and do all sorts of things. So there's a different set of combinations of what you can do. And then there was Edelweiss presented this for Oracle Analytics Cloud. You can access Oracle Analytics Cloud directly using OML notebooks. This is actually a very simple scenario. I have my project in the Autonomous database, and I can export this and take it to an on-premises database and deploy the model there. This is a very common scenario where people train something here and they transfer it here, or they train something here and they transfer it here. So the ability to move your data models around actually make this really popular. And the same thing for exporting in ONX format. Now, Oracle has got a new service called the OCI Data Science Service. This is a generic machine learning service. It is not tied into the DB, but it allows you to do a lot of stuff along with the DB. You can export anything from scikit-learn, TensorFlow, PyTorch, MXNet, and then you can import these models into Oracle ML services. There are a couple of new services we announced last week. I just want to spend 2 minutes going through this, and then this will be the end of my presentation. So the first one is the OCI language service, and this performs text analysis. So this is to understand unstructured data in documents, and it has built-in training models to do sentiment analysis, text classification, as well as named entity recognition. The second one is OCI speech. This is again trying to understand speech and using pre-recognized models to do speech recognition. The third one is for vision. This is for image recognition and for document analysis. And this can be also used to detect anomalies in manufacturing as well as business flows. The fourth one is for anomaly detection. Remember, we spoke about this MSET2 algorithm that is used. It's used for many different purposes right now. Nuclear health, reactor health monitoring, fraud detection, predicting when your equipment is going to break down. We use this sort of internally to look for machine failures. And you can receive data from multiple devices to predict failures. So this is called the OCI Anomaly Detection Service. Then there's the OCI Forecasting Service. This helps you to create accurate forecasts for revenue, resource requirements, and stuff like that. You no longer need to know how to do this. You just can look at these time series forecasts based on what the service provides you. And the last one is Oracle Data Labeling. This is for helping label data sets to train AI models. So to summarize, Oracle has a whole bunch of stuff with AI and machine learning, okay? And these are the last set of services, including the Oracle Digital Assistant. I think somebody presented on Oracle Digital Assistant. And then this is what we spent most of our time on, is understanding Oracle machine learning. I think Edelweiss Kammerman probably covered Oracle Analytics Cloud. And then there's a whole bunch of data catalog and data management services, which we did not have time to cover. But so these are the various functions that are available in Oracle as part of the machine learning portfolio. I have this slide, which you will get as part of the presentation. It has links to all the stuff we spoke about, demos. We have this live labs here that you can actually go and click and run these experiments. This is actually pretty cool. There are videos here for AutoML UI and for OML for Pi. So this will be included as part of the presentation. And that's it. Any questions?
Thanks a lot, Sandesh. We appreciate that content. Anyone has questions? You can do it through the chat in English or in Spanish.
I think it's been a long day, right? Everybody's been busy on something.
Yeah,
One of the advantages of being the last session is everybody gets to go home now. or maybe someone's presenting after me.
So it seems that there are no more questions. So is there any final comment or advice that you would like to share with the public?
All I can say is if you're not into machine learning yet, you should get into it. It's not that difficult. I've spoken about this multiple times in the last couple of years. Now it is so easy because you can use you can use all these AutoML UI tools to get into machine learning without actually having to have much of a learning curve on this thing. It doesn't matter whether it's Oracle or not. Just get into some kind of machine learning, understand something, build a model, train your data sets, look at some examples of how you can solve this using machine learning. Okay, there's a lot of pre-existing pre-built use cases that you can do all sorts of interesting stuff. I know that me, Edelweiss, and Rita Nunes actually ran a lot of labs when we were doing in person. Hopefully next year we can restart that and we can run some of these labs again. There's a lot of stuff that has actually happened since the last 2 years in the labs and all the things that you can actually do. So hopefully when Edelweiss and Rita start doing these things again and we start going to universities and running this, you can. The autonomous database account is free. Just create a free account and start using these services. If you have downloaded Oracle 21.3 on premises, you can actually use most of these. You can build most of these machine learning use cases using an on-premises database on your VM at home. So there's so many ways to get into this. And if you're already an Oracle DBA or developer, it is just a couple of lines of SQL to learn how to write machine learning code. So don't waste time getting into it. It's very, very interesting once you start working on it. It also improves your resumes. More dinero, when you get better, get machine learning into your resume. So, that's pretty good.
Yeah, great advice. Thank you. There are a couple of comments that I will read. Jorgelina from Argentina said, it was a lot of info to think about it. And it's almost 9 p.m. in some places. Thanks for the info. Trying to learn about machine learning.
It's time to get the tequila out. That's what you should start the session with, right?
Yeah. That's what we miss from the presential events, but we will be together soon.
There's a lot of introductory links in my presentation. So even if you don't understand most of it, it's okay. Just start off with the links that are in my last slide, and you can click and see the demos and slowly start learning about it. I mean, when I started learning about this, I didn't know anything about it either. And in 3 years, I've learned so much about it. And I've actually had the opportunity of learning a lot from my friends in Latin America, especially, Edelweiss and Rita, who know this space. We've done quite a few labs together, and I really enjoyed that. So I learned a lot from these people. And it's like you have to, it's a fun process, right? Just take it easy, learn as much as you can, and, just keep getting better and better about it.
Yeah, I agree. That is the most important benefit from following these kind of communities and sharing knowledge.
Il è difficile. No te preocupe.
Yeah. You have to learn the pura vida term from Costa Rica.
Pura vida is easy. Everything is pura vida as far as that's concerned, right?
Yeah, it's a lifestyle. So Jorgelina just want to clarify that there is not tequila in Argentina. She has mates, and she says that she's also an Oracle Apex developer, and
excellent.
You wonder if MI can be applied in some of the things that she does.
All the functions in machine learning can be called through Apex. If you're an Apex developer, you basically fit right into this thing. You can write all your models using Apex functions. So most of our applications internally within Oracle are all written using Apex, using machine learning functions written on the Oracle database. At the end of the day, it's all SQL and PL SQL. So if you're an Apex developer, you're right at home. And yes, I have to come to Argentina to educate myself a little better. In 2019, I think Argentina was one of the countries that I did not visit. So good point.
Yeah, great. It's a beautiful country also. So I appreciate everything on behalf of the organization. I Thank you again for your time, for your preparation, for your attitude, and for all your advice. Estamos muy contentos de haberte tenido aquí, Sandesh. Te agradezco en nombre de todos, de la organización, de la comunidad de developers, en nombre mío personalmente también. Ha sido un placer tenerte en esta sesión cerrando el evento. It has been a pleasure having you at the end of this event. I am inviting everyone to join on the final session. It should be very quick. And the director of the community is gonna make a wrap up. He will give some important numbers and what is going on after that, when are we gonna meet again. So it's very important that you can attend. All the sessions have been recorded and are gonna be posted on social media, and you are gonna receive the links through the email that you use for registration. So thank you very much, Sandesh. Have a wonderful night. Have a rest of weekend
Buenas
very
noches,
nice.
folks.
And come back soon, please. Gracias a todos.
Absolutely, looking forward to it.
Gracias. Quédense para la sesión de cierre que viene a continuación. En el link de la agenda está. Va a ser muy corta, pero es muy importante porque Rolando Carrasco, el director de esa comunidad, nos va a dar pues como un resumen de todo lo que ha pasado en estos 2 días, donde hemos tenido más de 40 sesiones, hemos tenido 3 idiomas en este conocimiento que hemos tenido de todo el mundo Oracle. Entonces los invito a que se unan un ratico. No se preocupen que las sesiones quedaron grabadas, las presentaciones van a ser compartidas al link que usaron para registrarse y a través de las redes sociales del grupo de usuarios. So thank you everybody and have a great night. Bye bye.
Take care, folks. Enjoy. Bye.